Hey math kids, welcome back to another G67 math video. Tonight we're going to be adding and subtracting positive and negative mixed numbers. Let's start off with our trivia question from the Crayola experience my daughter and wife visited yesterday. How many different colors of blue does Crayola have? I think you'll be surprised. Officially tonight we'll be adding and subtracting positive and negative mixed numbers with like denominators. So we're going to start off with just common denominators. Let's do this thing. Mary baked 2.5 dozen cookies for the party. Aaron baked 3.5 dozen more, and Mary Beth baked 4 dozen cookies. How many cookies were at the party in all? Well, I think you could quickly say that we could add up these wholes here. Here's 2 dozen from Mary and 3 dozen of Aaron. That's 5 dozen. Mary Beth made 4 dozen. That's 9 dozen total. Plus you got the 2 halves I could piece together to get 9 wholes plus 2 halves would be a total of 10 dozen. Yes, I could do that in my head. Bet you could too. This one here, we could also take and flip it into improper fractions. I could say 2 times 2 plus 1 is 5 halves here. Make this into an improper fraction. It's 3 times 2 plus 1, that's 7 halves. So now I have 5 halves plus 7 halves. That gave me a total of 12 halves, plus the 4 dozen that Mary Beth made. So I got 4 plus 6. I still have my 10 dozen here when I simplify my answer. I think what you'll find tonight, there's a couple of different ways that you can go about adding and subtracting mixed numbers with like denominators. Sometimes you have to convert to improper fractions. Other times you can go straight forward and do it in your head. It kind of depends upon the numbers involved and whether they're positive or they're negative. Let's review some stuff here. We got the numerator up on top. We got the denominator on the bottom. A fraction, well, that's part of something. It's not whole. A mixed number, that has some wholes and some parts, like 2 1/4. The words common and like, they mean the same denominator. And unlike denominators, those are different. So we'll be dealing with those in different lessons. You need to have that common or like denominator to add or subtract fractions or mixed numbers. Here's a real straightforward example to begin with. We have 3 5/7, and we need to take away 2 sevenths. Well, in this case, we could just take 5 minus the 2, and I've got 3 sevenths left. And then I still have the 3 wholes. So in this case, 3 3/7 is left over. I didn't even need to deal with the mixed number, really. I just moved it because this fraction was larger than the fraction I was subtracting. It doesn't always work that way, and I'll show you some examples where you have to do a little more work. One thing's for certain, you will have to know how to quickly go back between improper fractions and mixed numbers. So let's do a quick review. If you need to change from a mixed number to an improper fraction, multiply the wholes times the denominator, add in the numerator. 4 times 4 is 16, plus 1, 17/4 is your improper fraction. Just likewise, you need to be able to know how to go from an improper to a mixed number. Your improper fraction is 19/3. That means 19 divided by 3, so set it up. 19 divided by 3. 3 goes into 19 6 times. 6 times 3 is 18. And when I subtract it out, I have 1 remainder. I have 6 wholes and 1 part left out of 3 parts total. 6 1/3. I can do the discount double check on that one real quick too. 6 times 3 is 18 plus 1 gives me that 19/3. Real easy to check to make sure you have the right answers. All right, well, let's do some problems here. This first one doesn't appear to be that difficult of a problem. We have 3 1/3. We need to take away 1 2/3. Well, we're taking away a fraction that's bigger than we're starting with here, so I know I have to do a trade here. So I'm just going to put these into improper fractions. 3 times 3 is 9, plus 1 gives me 10/3. 1 times 3 is 3, plus 2 gives me 5/3. When I subtract 10 minus the 5, I have 5/3 left over. I can quickly turn that into a mixed number, which is 1 2/3. So what's the big deal, right? Well, problems aren't always that easy. Look at this one here. It gives me a headache. Negative 1 5/16 plus 2 9/16. You got all kinds of weird stuff going on here. In these cases, I think we just have to go right to the improper fraction and lay things out as well. So make it into an improper fraction. 1 times 16 is 16 plus 5 gives me 21/16, and that's negative. plus I'm going to add in 2 times 16 is 32 plus 9 is 41 sixteenths. So I'm now at negative 21, and I'm going to add a positive 41. I'm going to have 20 left over, because really what I have to do is I have these positives and I need to get rid of all the negatives first. So I can take 41 and I can subtract that 21. I'm going to have 20 positive ones left over, and you can think about it as a number line too. You're at negative 21. It's going to take 21 just to get back to 0, and then you'll still have 20 left to move forward. So you end up with a positive 20 sixteenths. Now you can quickly take 20 divided by 16 and you get 1 and 4 sixteenths. And here's that situation where that's not in simplest form. 4 sixteenths can be reduced to 1 and 1/4. See why that one gave me the headache? There's a lot of things you had to keep in mind in doing that. All right, let's take and move on to some problems for you to try. Why don't you go ahead and try solving this one to begin with. Negative 3 2/3 minus 1 1/3. You choose a strategy and go ahead. I'm back. Let's see what you did. Here's the way I looked at it. See if you can figure out how I did this. Just show you my work. See if you can follow my thinking. Were you able to? I put in a whole bunch of arrows to help you. Well, I took the 3. Because really what I'm doing here is it's a negative 3 2/3 minus a 1 1/3. That's really like a negative plus another negative, right? So I added the wholes. 3 plus 1 gave me 4. And I added the fractions. I had 2/3 and 1/3. And that really gave me another whole. So this is really a negative 4 plus a negative 1. Because all my fractions up here are negative. It's negative plus another negative. That's the same thing as a negative minus a number. So I had negative 4 plus a negative 1. I had a total of a negative 5. I was able to do that fairly simply. I didn't need to switch to my improper fractions. If you did, that's fine too. Negative 5 is the correct answer. Just remember, I'm going to type it up here. A negative 1 plus a negative 1 is really the same thing as a negative 1 minus 1. These are the same thing. You can add a negative or subtract, and that's what I did here. It was easier for me to think about this as adding a negative. So I could just say, oh, my negatives, I got a negative 4 here, negative 2/3 and negative 1/3. That's another negative 1. Put in my negative symbols down here to get a negative 5. All right, let's give you another try. All right, solve this one. Okay, here's how I did it. Well, this was minus a negative. So I said, well, when I have a minus and negative, that's the same as plus. So I just took and I rewrote the problem. Now I had a negative 2 1/5, and I was adding 6 4/5. So I didn't know what to do. I said, I'm going to just make these into improper fractions. 2 times 5 is 10 plus 1 is an 11/5, and that's negative. 6 times 5 is 30 plus the 4 gave me 34/5. So I was at negative 11, and I was going to add 34. Now, you notice how I don't even need to talk about the fifths in this case. I'm just thinking about myself being at negative 11 on the number line, and I'm going to add a positive 34. Well, 34 minus 11, that would leave me 23 positives, and it's really 23 fifths. I can take 23 divided by 5, and I get 4 3/5 left. And that makes sense too. You're at a negative 2, and you're going to add a positive 6. You're going to be at 4 something, right? All right. Here are your ticket to the show problems. Stay with me on this one. I know negative numbers can be a little bit challenging, but I think you can handle these two. Negative 4 3/5 plus a negative 2 2/5. Second problem, 2 3/8 minus 1 5/8. Okay, got a couple there to look at. The trivia question of the day: how many different colors does Crayola have, or how many different colors of blue does Crayola have? Currently, they have 19 blues. I thought this was kind of interesting. They have 120 colors they're using: 23 reds, 20 greens, 19 blues, 16 purples, 14 oranges, 11 browns, 8 yellows, 2 grays, 2 coppers, 2 blacks. one white, one gold, and one silver. Although Crayola crayons come in 120 different colors, the labels are only made in 18, which cover the full spectrum. Interesting. Okay, if you do look up on Wiki or something like that, I did notice that I saw like maybe 26 different crayons that had blue in the name, but you know, blue-green, that might be being counted as a green. So, because I kind of question that, it's like, what are all of those different blues? But this was actually a piece of trivia they delivered at the Crayola experience. So anyway, I'm pretty sure those guys know how many blues they have. Thanks for listening. Have a great day.